We are basically investigating a retrofitting technique to seismically upgrade existing reinforced concrete structures. So especially older structures which have been built in the 50s, 60s and 70s. Back then we didn't know a lot about earthquakes, and they were non-seismically designed. So the probability that if an earthquake strikes, it's very high that they don't behave well, and the extreme event they may collapse. What we want to see is the beam column joint behavior. And during lateral loading, a lot of stresses pass through that joint. And in a lot of earthquakes in the past, we could see that those joints may fail in an undesirable manner.
The two full-scale tests are a great and unique opportunity to verify and test the findings and concepts that we have gained in our earlier research. In previous experiments, it has been shown that the success of the strengthening solution is highly related to the performance of the anchorage. Our onded anchor system using FISIM Plus provides an excellent performance with its high stiffness and low displacements at high load levels.
The previous structure which we tested without the strengthening solution, all the damages were concentrated in beam column joints. And now in the second test, the beam column joints were almost undamaged. There are some fine cracking, which of course we expect, and that is absolutely fine, but nothing where we saw any damage either to the anchors or to the haunch elements.
In order to have an effective performance of those haunches, whose aim is to basically redistribute forces around the joint, so we want to protect the joint and induce failure in other parts in the structure, we need a strong connection. And for that, we use the Fischer products, because Fischer is among the most renowned companies worldwide when it comes to anchorages. The haunches were connected with post-installed adhesive anchors. And this adhesive is the Fischer epoxy mortar FISIM 390 Plus, which is very stiff. The stiffer the anchors are, the more forces flow through these diagonal haunch elements, and the more we can protect those joints.
There is a beam column joint where the columns and the beams are connecting, which is an interior region of the structure, and that is not possible to be reached by other strengthening methods where we add some additional reinforcing elements. Now with this method, we are doing the strengthening around the joint core, which distributes the forces around the joint core and thereby protects the joint. So with this method, we can then enhance the capacity of the structure, its behavior, its ductility, and we can prevent the collapses. So which makes it not just scientifically relevant, but also relevant in the real world situations to prevent loss of lives. And with the Fischer anchors, who also have the approval for up to 120 years service life, once we install it, we don't even have to worry about the maintenance anymore, because once it's there, it's a no maintenance system. You just install it, you go, it does its job well. So that's why I think this is groundbreaking result, because the system is very efficient. It works. For the first time we showed it at the structural level, and I must say at the structural level the results are even better than what we performed at the beam column joint subassembly level.
Due to global challenges such as the climate change, the construction industry needs to become more sustainable, with a focus on preserving existing structures where possible instead of demolishing them and building new ones.
International research cooperation is quite